Hello, we are the composting team of the Green Campus Enterprise. I am Drew Eaton.
And I'm Maddie Krzyuk. I'll go over a quick overview of what we'll be talking about today. First, we'll go over the background of our project and a little bit about composting. Then we'll talk about the benefits and regulations of composting. Then we'll talk a little bit about the work that we've completed so far and some of our future goals for this project. First and foremost, what is composting? It is the recycling of food and other organic waste. It provides a range of environmental benefits, including improving soil health. It reduces greenhouse gas emissions by diverting food waste away from landfills. It also recycles nutrients back into the ground, and it helps mitigate the impact of droughts. Anything that grows will eventually decompose, as we all know, but composting speeds up that process and creates a valuable resource that we like to call black gold, which is soil rich with nutrients that plants love.
Why should Michigan Tech compost university-wide? Landfill diversion is a big reason. Food and other natural waste can be composted instead of sent to the landfill to produce greenhouse gases. Carbon sequestration. Compost does a great job of storing carbon in the soil, preventing it from getting into the atmosphere and growing healthy plants as well. Methane emissions. When food decomposes in a landfill, methane, a far more harmful greenhouse gas than carbon dioxide, is released into the atmosphere. Water retention. Compost's ability to retain water has many benefits, including erosion prevention and the obvious, saving water. Soil enrichment. This extensive list includes pH balance, nutrient balance, and making plants healthier and less susceptible to bugs and diseases. And habitat restoration. Compost can reintroduce nutrients into ecosystems that have been contaminated or eroded away. There's multiple types of composting facilities. These are just a couple. Windrow composting in the top left is a large-scale operation that takes up a lot of room. The waste is formed into long piles that are turned and aerated periodically. There's also a covered auger, a covered mid-size automated compost system that mixes, aerates, and adds moisture with little labor necessary. And there's in-vessel composting. Lots of different varying sizes and capacities. In-vessel composting can quickly and controllably turn organic waste into a high-quality compost product. And there's vermicomposting as well, which we won't be looking at as closely. It's a very small-scale operation and is aided with the use of certain species of worms. Useful, but not on a university scale.
When it comes to composting regulations, we turn to EGLE, which is the Michigan Department of Environment, Great Lakes, and Energy, to help guide us on what we can do to compost correctly. First and foremost, when it just comes to what we can compost, we look at yard clippings and food waste. So the university obviously provides a lot of food waste and yard clippings from daily operations. And via EGLE guidelines, we can safely mix those two together in one large compost. And we do not have to necessarily register with EGLE for these regulations. We can just go ahead and start composting whenever it works out with facilities. But we also want to make sure that residents are near and around the composting site do not have to deal with many nuisances. We would want to install some buffers around the composting to prevent noise and odors from reaching those residents. We also don't want water to be pooling around the compost, and we want to keep pests out of the compost, obviously. We also want to make sure any wastewater from the compost will not get into any neighboring streams or rivers, and too much water in the compost will create anaerobic conditions in the compost itself, which will become a sludgy mess. Just some general composting criteria. We want to make sure that our compost stays in the carbon to nitrogen ratio of around 30:1. So everything we'll be composting will have carbon in it because all organic matter is made up of carbon, but we also want to add some nitrogen-rich materials, which will be the food waste coming from the dining halls and also some grass clippings. We also want to make sure that the composting piles are around 110 to 140 degrees Fahrenheit. This temperature range indicates an active pile, which will produce good and healthy compost by the end of the entire process. And this heat is the result of microbial decomposition of the organic matter itself. We also want to make sure that the compost piles can handle the nasty Houghton winters. Obviously, the piles will become colder and it'll take longer for the composting process to take place, but we can help the process continue by insulating the piles with leaves and to turn the piles less often just to keep the heat trapped inside. A quick overview of one of the proposed sites that we've been looking at. This site is just northeast of the facilities storage building in Houghton. It is accessible from Cemetery Road. However, it is 1,300 feet from residential properties. So we want to make sure that there's not too many nuisances, such as odor or large noises coming to those houses. We would have to install electricity and cut down some trees, but it is a decent size for a windrow operation.
And size is a big requirement that we're working with. So we designed a facility size design calculator. The purpose of this calculator is to help us understand what kind of size requirements there are for different facility types, all based on the amount of food and other waste that's created in a day or week. The calculator starts with a variable input that can be changed based upon any new feedstock data that we get, and those inputs are sent to their own respective sheets based on the facility type as seen here. Each sheet has columns to calculate all of the different areas that must be accounted for. Each sheet also has a list of about 20 constants that are standard dimensions and other rules of thumb for facility design. And lastly, each sheet has a shorter list of variables that can change based on different user inputs. After adding up the total square footage of all the areas, a final site size is computed in square feet and acres on each sheet and to the right of the initial input numbers as well. Some things we plan to keep working on are getting consistent and accurate food waste data from Michigan Tech. We want to determine a final site location eventually, perform a cost analysis and environmental analysis to compare facility types more in depth, and finally to design a composting facility. Thank you.